We've worked with quadratic equations in Chapter 10 and solving them, setting them to zero, factoring, and finding the solutions. Now we're going to take a look at graphing quadratic functions. So to have a quadratic function, then we're going to need the input value, x, and the output value, y. So what you see here, y equals ax squared plus bx plus c, that's the standard form of a quadratic function. Now it says where a is not equal to 0, because if a were 0, what would happen? Yes, the x squared term would disappear and then it would just be a line. The graph of every quadratic function is a parabola. It's a U-shaped graph if it opens up, or it can be an upside down U if it opens down. How it opens is determined by the leading coefficient. And leading coefficient, remember, means the coefficient of the highest degree term. In this case, x squared. So whatever that a is, if it's positive, the parabola is going to open up. If it's negative, the parabola will open down. So here we have two parabolas already graphed. So at the top it says, what is a? So here's the equation of the one on the left, y equals x squared. So what's a? 1 is the correct answer, the coefficient of x squared. And on the one on the right, notice that the coefficient of x squared, or a, is -1, and notice that the parabola opens down. So if a is positive, it opens up, negative, it opens down. Now, one term, the vertex, that's the point where the parabola turns around, whether it opens up or down. So the vertex on the first diagram here is 0, 0. The vertex on the second one is 0, 4, the turnaround point. The extreme value is considered to be the highest or lowest value. Now notice, the x's don't have an extreme value. They'll go forever to the right, that's what the arrow means, and forever to the left. But the y has an extreme value. In the first graph, it's the lowest value, which is just a y value of 0. And in the second graph, it's a highest value, which is a value of 4. The axis of symmetry, so you probably know what symmetry is. Things are a reflection of each other on either side of something. So you've probably seen it in biosymmetry in some of the systems in the body, and sort of even our own bodies. We have a right arm and a left arm and things like that. But for the parabolas, the axis of symmetry is this line that the parabola is on either side of, sort of equidistant, same shape. So for the first graph, it's the y-axis, which is the equation. Come up with the equation of the y-axis. Okay, hopefully you said x equals 0. And again, it's exactly the same on the right graph, because the y-axis is again the axis of symmetry. One more thing about the extreme value before we leave these graphs. When we get to word problems, that's usually the part that we want. For example, if you can put your profit statement as a parabola, as a quadratic, then every company's looking for the highest profit. So we're looking for that y value of the vertex. That becomes the highest profit, or that extreme value. Same thing if you had a cost function and you want to minimize your cost. You're looking for the lowest cost, and that would be the lowest value. Again, the y value of the vertex is the extreme value. So now we're going to start graphing these quadratic functions and see what the parabolas look like. So we're going to start with a nice little short equation, y equals -1/2 x squared. So just like I've been mentioning throughout the year, you should feel confident that you can graph anything. Really, all you need is a table of values. All right, so we're going to create a table of values. And the nice thing is you want to just make up numbers that are easy for yourself. So if we let x be 0, of course, in this one, y is 0, and we can plot that point. And if we let x be, let's say, 2, we square it to 4. -1/2 of 4 is -2. So we're going to graph 2, -2. And then notice if we put in a negative 2 for x, we'll get exactly the same thing, because we'll get 4, and then times negative a half, it'll be that negative 2. Okay, so let's try let's try 3. So 3 squared is 9. Negative a half times 9 is negative 4 and a half. I have to put in the negative 2 up here. Okay, so when we let x be 3, then y is negative 2, 4 and a half. So it's right about there. And same thing, of course, if we plug in a negative 3, we get negative 4 and a half again. So we get this point down here. All right, so literally what you need when you graph these is you just want to see the shape. So to round that out, because it almost looks like it could be a V, I'm going to try one more number. I'm going to plug in a 1. So 1 squared is 1, of course, times negative a half is negative a half. So when y is 1, x is 1, we get y is negative a half. So you can see that, and we'll have the corresponding symmetry point on the other side, right? When x is negative 1, we also get negative a half. So hopefully you can see that this is a little more rounded than a V, and it should go through the origin. So sorry, my drawing was a little off. Okay, so that's what the parabola looks like. So if we run through what's the vertex, even though mine looks a little off, remember that turnaround point is 0, 0. What's the axis of symmetry? Again, just like the other two we looked at, it's x equals 0, which is the y-axis. It opens down. Again, notice that A is negative a half, so yes, we know it opens down. Okay? Okay, here we have another one with a few more terms this time. So again, we're going to do a table of values. So let's say we let x be 0, which is the easiest number to plug in. We get negative 3. So when x is 0, y is negative 3, so we have our 1 point on our graph. So I'm going to plug a 1 in. So I get 1 minus 2 is negative 1, minus 3 is negative 4. So 1 gives me negative 4. Now if I plug in a 2, I'm going to get 2 squared, which is 4, and then minus 4, 0, and then negative 3, so I get negative 3 again. So when that happens, and you're just plugging in numbers, and you get a symmetry point, because notice when x was 0, we also had a negative 3, then you know midway between those 2 points has to be the axis of symmetry. Which means right now, unless we made a mistake, we know that our vertex is that lowest point there, which happens to be 1, negative 4. So there's the vertex of our parabola. So let's plug in another number. We're going to plug in 3 and just make sure we're doing it right here. So we plug in 3 and we get 9. Minus 6 is 3, and then 3 minus 3 is 0. We plug in 3, we get 0. So now I know there should be a symmetry point. Again, remember, if I was correct about the vertex, then the axis of symmetry, which I'm dotting here in red, should go right through the middle of the parabola. So if you notice that this point we just did, 3, 0, was 2 blocks to the right of that line, then we should have a symmetry point 2 blocks to the left. So I'm going to verify that. I'm going to plug in negative 1. I'm going to make sure I get 0. So negative 1 squared is 1. And then minus 2 times negative 1 is plus 2. And then minus 3. So I do get 0, and I've verified that my work is correct. Again, for shape, I'm thinking a U shape, so I just want to be careful that I don't make it look like a V. I'm going to just try one more point. I'm going to plug in a 4. So 4 squared is 16, and then minus 8 minus 3. So we get 8 minus 3, which is 5. So at 4, we get 5, which is that point right there. So how many points do you need? Well, you just have to be able to draw the parabola accurately. So that point helped me extend this and, know the shape. There's a chance sometimes if you don't have too many points that you fling it off to the side or make it too narrow or something like that. So the amount of points that I had here helped me draw an accurate picture of this parabola. So the vertex we had was 1, -4. The axis of symmetry, what's the equation of that? So look at that in a moment. What would be the equation of the axis of symmetry? Again, I dotted it in red there. So hopefully you came up with x equals 1. That would be the axis of symmetry. Let's make sure that axis is aligned. So there's your axis of symmetry, x equals 1. Now I was kind of just lucky on this problem that the first 3 numbers I plugged in for x, 0, 1, and 2, actually gave me the vertex and showed me the symmetry. Sometimes the parabola can be a lot further away from the y-axis, and it might take a while before you'd get that point, or you might plug in an x value and you get a really high number. So we actually have a little formula that we can use to find the vertex first if we want, and that is that the x value of the vertex, so I'll use a v for the vertex, the x value of the vertex will always be the opposite of b over 2a. And then once we get that number, we're just going to plug it in to get the y value. So let's just check it for this problem. Our b value was -2, so the opposite of b is +2. Over 2a, our a value was 1, so 2 times 1 is 2. So we got 2 over 2, or 1. Notice that was the x value of my vertex. I have it down there at the bottom of the screen. So that checked out. So sometimes you may want to do that first. So here's some of the things we can just pick out by looking at the quadratic function itself. So remember, a is the leading coefficient, the coefficient of x squared, b is the coefficient of x, c is the constant. So if a is positive, the parabola opens up. If a is negative, it opens down. The vertex always comes from the x value of the vertex is negative opposite of b over 2a. And the axis of symmetry, so let's just take a look at a parabola. So if this is my parabola, then the axis of symmetry, of course, has to go right down through the vertex because that's where the middle is. So whatever that x value of the vertex is, that's going to be the equation of that vertical line, x equal that number. So if that vertex right here happens to be 2, -3, let's say, that vertex, then the axis of symmetry is x equal 2. It goes right through that vertex, that x value. The other thing we can get from that equation of the function is the y-intercept. Because notice, if you put 0 in for x, you always get that c value. So for the one I just graphed here, it looks like if that's vertex is 2, 3, maybe that c value is 1/2. And that will be our y-intercept. So often when we graph parabolas, we want to just go through these 3 basic steps. Find the x coordinate of the vertex first, using opposite of b over 2a, and then make a table of values using values, x values to the left and right of the vertex, plot the points, and connect them. So we'll try that on the next one. Okay, here's one that might look a little harder. Now I might just start with, even before I do the vertex, I might just look up there and say, okay, what's the y-intercept? Right? Put a 0 in for x, we get our y-intercept is -6, and I've got 1 point already, a nice easy little point. Now if we're going to do the opposite of b, so -8 over 2a, -4, we get +2. That means that we know our vertex has an x value of +2. So we're just going to plug that in and find the y value. So if we plug that in, we get -2 times 4, or -8, and then plus 8 times 2 is 16, so now we have +8, minus 6, so we get a +2. So we know our vertex is at 2, 2. Now, I already had that point 0, -6 down there. So let's just see if that seems to make sense. Because now I'm saying the vertex is up there at 2, 2. Well, sure, because look at A. A is -2, which means this parabola should open down. It also means then that I know the axis of symmetry should go through that vertex. So if I draw that in, that can help show me where some symmetry points are. So since I have that point down there at 0, -6, I'm pretty sure, unless I made a mistake, that I'm going to have another point over here at 4, -6. So that's a good one to check. So again, at this point now, I'm just plugging in values for x and finding y to help me shape this and to verify that that's correct. So I'm going to plug in a 4 because I want to see if that's correct. So 4 squared is 16. -2 times 16 is -32. And then plus 8 times 4 is +32. All right, so now I have 0, and then I have -6. So yes, I verified that that point 4, -6 is correct. So now I have some nice boundaries on my vertex, on my parabola. So now I just want to fill it in so I get the shape better. I don't want to draw a V, and I just don't want to make up a U. So just look at it. A good point, a good x value to plug in would be a nice easy one of 1. So I'm going to plug in 1. And this time I've been using this technique of writing out each one. Not a bad idea as they get a little more complicated. So to the right of my table here, when I plug in a 1 for x, I'm going to say -2 times 1 is -2. And then plus 8 times 1 is 8. So now I'm up to 6. And then -6, so I get 0. So at 1, it looks like we go right through the x-axis. And now if I'm pretty confident in my work, I know that 3 will also give me 0 because I've already checked the symmetry and I know that's correct. So now I'm ready to just connect my points. Whoops, I didn't do that too well. And draw my parabola. Okay, so again, when you go through the steps, I did plot the y-intercept first, that -6, nice easy little point. And then I found the vertex, the opposite of b over 2a. That's the x value of the vertex. And then I plugged it in to get the y value. Right, and then I chose my symmetry point. Since I already had the y-intercept, I said, oh, let's just see if that checks out. So I plugged in 4. Sure enough, I got -6. And then just to check for the shape, I plugged in a 1. Okay, now I think it's time that you try to graph one. So I want you to hit pause as soon as I give you the quadratic function and grab a piece of graph paper and try this out. So I'd like you to graph y equals x squared minus 2x minus 8. So hit pause, grab a piece of graph paper and graph that one. So I'll quickly review the steps hopefully you went through. So the y-intercept would be -8, so you can plot that point. Again, you have 1 point then, 0, -8. If you find the vertex, the x value will be opposite of b, so +2 over 2a, which is 2. 2 times 1. So you get 1. When you plug in 1, you get 1 minus 2 minus 8. So you see that your vertex y value is -9. So we're going to plot 1, -9. Right there, and that should be the turnaround point, which means you should have a symmetry point at 2, -8. So if you want to verify that, again, what I'm doing, basically instead of doing a table of values, I'm kind of just checking to make sure, because I'm pretty sure it's going to be at 2. So I'm going to plug in 2, and we'll get 4 minus 4 minus 8, and sure enough, we get -8. So that's correct, but I definitely need more points for shape. So I would either plug in, what's around that, either a -1 or a +3. So let's try a -1. So -1 squared is 1. And then -2 times -1 is +2 minus 8. So we get 3 minus 8, which is -5. So for -1, we're going going to get -5. And then at this point I'm confident, so I'm just going to put the symmetry point in. And I would do one more point because we're so far away right now from the x-axis. So this time let's try 4. We get 16 minus 8 minus 8, so we get 0. So when x is 4, y is 0. Again, equidistant. Let's draw the axis of symmetry in. Again, so we want the equation. We know that equation would be x equal to 1. And then, since that last point 4, 0 was 3 blocks to the right of the axis, I'm going to go 3 blocks to the left of the axis. So now I feel pretty confident about my shape. Draw that parabola in there. Now, one other thing that I haven't shown you yet, if you go back to what we did in the last chapter, or chapter 10, you're going to take a look at the x-intercepts. So how do you find x-intercepts? Remember, you plug a 0 in for y. So if we plug a 0 in for y, and sometimes this is easier if the numbers aren't matching up for symmetry, which I'll show you maybe on the next problem. But you could let y be 0 and just factor this, right? This factors pretty easily. Trinomial, x times x. Factors of 8 that subtract to give me -2. Right? I need a +2, and a -4. So I know I should get x-intercepts at -2 and +4. And now look at our graph. That's exactly where we had them. So you may choose, if something looks easily factorable, you may choose to do that first. Notice, if I had done that first, factored this and found those two x-intercepts, then I would know, since they have symmetry, because the y value would be 0 for both of them, I know that the axis of symmetry is midway between. So that's going to come in handy a lot of times. Okay, we're going to do one more graph. I know you'll be doing some more in class tomorrow, but I'm going to do one that's a little bit funkier. So if I just work on a table of values here this time, and I'll show you why in a minute, but if I let x be 0, of course the y-intercept is nice and easy, -3. If I plug in one value for x, I get 2 minus 5, which is -3, minus 3 is -6. So I'll plot 1, -6. Then if I plug in 2, I get 2 times 4, which is 8, minus 10, -2, minus 3, which is -5. So at 2, I get -5. So notice that looks a little odd. Obviously my symmetry is not going to go through x equal to 1. So what that's going to mean is that our vertex, the x value, is not at an integer. So this is one of those places where I might decide, I think I'm just going to factor this first. I just want to sort of verify that that's the case. So I'm going to let y be 0 to get the two x-intercepts. So if y is 0, I have 0 equals 2x squared minus 5x minus 3. So I'm just going to factor that. So 2x times x, my first term times first term. So the -3, again, I want different signs to subtract to get -5. So as long as I put the -3, so it'll multiply by the 2, and put the +1 there. Just verify it, 2x squared minus 6 plus 1 minus 5x minus 3. So it means my x-intercepts are -0.5 and +3. So let's put that in the graph now. So +3 and -0.5. And now we would know that the axis of symmetry has to be midway between those, and that's why this looks a little funky. So the distance between those two x-intercepts is 3.5, which means if that's 3.5 blocks, then I have to go 1 3/4 blocks. In other words, 3.5 is 7 halves, so half of that is 7/4. So I need to go 7/4 or 1 3/4 blocks away from both of those. So from the right one, 1 3/4 blocks over, it puts me right 1/4 of a block past 1. So 1 1/4 that's where my vertex is going to be. Notice it's 1 3/4 also on the other side to get to that other x-intercept. So I'm just going to check that with that vertex, opposite of b over 2a. Let's see if it is funky like that. So for the vertex, opposite of b is 5, over 2a is 4. Absolutely, there I've just verified that those two x-intercepts are right, because the vertex x value should be at 1 1/4, which is exactly where it looks like I thought it should be by just the symmetry of the two x-intercepts. So now, here's where the arithmetic gets a little harder. We've got to put the vertex. You can't draw your parabola without the vertex there, so we have to do that arithmetic. So I'm going to go back up here and just and erase this table. No, I'm not. For some reason it's not erasing, so we'll do it a different way. So I'm going to plug in 5/4 and just do the arithmetic here on the left, right underneath the x-axis. So it'll be 2 times 5/4 squared, so 25/16. Don't get thrown by the fraction, it's just going to be arithmetic. And then minus 5 times 5/4 is 25/4. Remember, 5 is 5 over 1, so 5 times 5 and 1 times 4. And then minus 3. So I'm going to reduce the 2 into the 16. So I have 25/8 minus 25/4 minus 3. So I need a common denominator. So I'm going to change my 25/4 to 58, and then minus 3. Now just combine. 25/8 minus 58 is negative 25/8. And negative 25/8 is just negative 3 1/8. So we have negative 3 1/8 minus 3. So we know the y value over here is negative 6 1/8. So I'm just going to see now. That would make it look like we had good symmetry. So 6 1/8 is just a little bit below, so it's a little bit hard for me to graph that on here. But now I would know that the symmetry would be a 1/4 on the other side. All right, it's a little hard to get it in there. And all of these points would definitely have symmetry. So this point that's at 2, -5, it's 3/4 of a block away, so I need to go 3/4 of a block away on the other side, and there's the symmetry point. So now the parabola's looking a lot nicer, and I'm going to just connect my points. Whoops, I didn't do that very well, but okay, it's a little bit easier, I think, with your pencil on your paper. All right? So the key here is don't be thrown by the arithmetic. Just take your time, get your common denominator, add, and be willing to maybe put in a 0 for y and factor. That might be a little bit simpler. So if you get this funky arithmetic that you think, ooh, I don't want to plug in that x value for the vertex, you may want to check it by factoring first and see if it at least seems reasonable. So now that we've talked about parabolas and what they look like as you roam around out in the world, start looking for them. Okay, I've got a couple drawn here. All right, the mathematics, a bridge to the world, actually is the Golden Gate Bridge there. I'm pretty sure that's what it is. Anyway, that's on my website, so you've probably seen that. And then the McDonald's arches, of course. So be on the lookout for parabolas, and when you see some cool ones, come in and tell us. So one last idea. A lot of times quadratic functions are just what happen in real life because something has a parabolic motion. So in this example here, at the beginning it says when an object has little air resistance, its path through the air can be approximated by a parabola. You've probably seen that throwing a baseball. You've seen that path, and it certainly looks like a parabola. So here is a gymnast who, or track star here, that threw the shot put, and the path, as you can see right here, is given by that quadratic function. So the question here is, again, that in that formula, 5.5 was the initial height at which she released the shot put. and that equation represents the height all the way on the path. So the question here, A, is what's the maximum height? So as soon as you hear that word maximum or minimum when you're dealing with a quadratic function, hopefully you're thinking of the vertex, right? Because that's going to be the highest point. So what we would want to do here is find the vertex. Now, from one like this with the messy arithmetic, I'm definitely going to use a calculator, which I will show you. But again, it's simply punching out the opposite of b over 2a to get the x value. Just punch it on the calculator and then plug it back in. The second thing, what was the distance? We actually have not gone through that yet. We're going to talk about that because this would not be one that I would want to factor to find the zeros on it to see how far apart they could be. And shortly we're going to learn another method of finding those x-intercepts, those zeros of a quadratic function. But let's look at the maximum height. So there's your opposite of b over 2a. So you get about 34.61. Plug it in there, you get about 21.6 feet, which would be the maximum height. So again, the only thing that makes this more complicated, you're just going to punch those numbers out on the calculator. It just looks like it's hard. So looking at that maximum height on the graph, it looks like that. Again, what we'll be doing eventually, finding this maximum distance, we're going to want to know that length and find that number, and for that we need another formula, which we'll do a little bit later. So that's it. Tomorrow in class you'll be working on graphing some of these quadratic functions.